Okay, Chapter 5 teaches about trigonometry, and before we get too far into trigonometry, I just wanted to review some of the basic parts of trigonometry before we go too far. First of all, here's a little funny phrase that you might want to remember, SOHCAHTOA. SOHCAHTOA. So, if it's easy to remember as, like you putting your foot in a basin of water, that's fine. I've always thought it sounds kind of Native American, SOHCAHTOA, I don't know. Anyway, what it stands for is that the sine function is the opposite side of the angle over the hypotenuse. So it's the ratio of the opposite side to the hypotenuse. So that's the SOH part. So, cosine is the adjacent side of the triangle in ratio with the hypotenuse, so adjacent over hypotenuse. And TOA is that the tangent of the angle is equal to the opposite over the adjacent. SOHCAHTOA. And then you have your other three trig functions, which are really just reciprocals of the first three. So in other words, cosecant is just sine flipped upside down. So it is hypotenuse over opposite. Secant is hypotenuse over adjacent, since it's the reciprocal of cosine. And cotangent is the reciprocal of tangent, so it is adjacent over opposite. So those are just some of the basic facts that you should know about those 6 trig functions. Now, if you're looking at a unit circle, then what we usually do is we split that circle up into 4 parts, which we refer to as quadrants. So quadrant 1 is the part of the unit circle where x and y, the coordinates of a point on the circle, are both positive. So x and y values are both positive. Quadrant 2, the x values are negative, but the y values are positive. Quadrant 3, x and y values are both negative. And quadrant 4, x is positive, but y is negative. Now, when you're dealing with the unit circle, you generally want to refer to the angle, which is sometimes called the reference angle, as being the angle that your side makes with the x-axis. Okay, so that's sometimes called the reference angle. Okay, so with these definitions from above, where we have these triangles, and we define these trig functions using opposites and adjacents and hypotenuses, we can redefine those trig functions using x and y in reference to the unit circle. So in this case, the sine function, well, if you look at this triangle as your example here in the first quadrant, you see that the opposite of angle theta is this side, which would represent the y coordinate of the terminal point. So sine can be expressed as y over the hypotenuse, which in this case it's a unit circle, which means that it's a circle of radius 1. So all of these radii are equal to 1 in length. So it's y over 1, or just y. Now, if you had a different radius, you could call it something like y over r, and then it would be y over r, whatever your radius happened to be. But then, of course, the y value would be in scale with the radius, and you could scale it down to a unit circle. Similarly, cosine, the adjacent side of this triangle, is represented by the x coordinate, and then, of course, you're dividing by the radius, which in a true unit circle would be equal to 1. The tangent is opposite over adjacent, or in other words, y over x. And then your other 3 trig functions, just like before, are reciprocals of the original 3. So here you would have r over y for cosecant, r over x for secant, and x over y for cotangent.